Hi. So, in this, we are just going to implement firstly just a queue, which could in which like we could add new messages and also add last remove from it. So basically, just a simple queue, and and then we will be doing it. So there's a bit of a twist, and the twist is that we'll be like enqueuing to the queue in through like multiple threads, and we'll be queuing around 1 million of items and also removing all of them or dequeuing all of them. So what I'm expecting is like some kind of some kind of uh, race condition, and so because of the like same resources that we are using, same resource, that is q. So since we'll be using same queue, and we'll be like enqueuing 1 million of items through multiple threads, we would be seeing like a lot of threads like enqueuing the um, same item, and because of that the total number that we'll get at the end could be like a little lesser, and then we'll like try to resolve that race condition resolve the race condition using some kind of locks. So yeah, let's get started. So I'll just take like normal queue, which would be like a normal queue implementation would be linked list. And first of all, we could like define some of the important variables in here. Let's get this one. So let's say the number of items and number of items. This is, let's say, 1, 2, 3, 4, 5, 6. 1 million of items that we want to like put into the queue, and then a normal queue that we'll be using. It would be of type integer. Let's import the one that we need, and let's name it. Let's give it a proper name, queue new linked list. Okay, so we have got the queue, we have got the number of items, so I think we are good, and if we need anything else we could add it later. So let's say, and also like number of threads that we want to use to like process this. So to be convenient and understanding the limit of the system, let's call the int thread pool size to be 8. We are not actually using the thread pool, but yeah, since we'll be using 8 threads for this example, so let's just call it the thread pool size, and later we could like actually use the thread pool and like uh, pull the threads from there whenever they are available, and put it back when they are done with their work. So I think we are good till here. We have this many threads. Let's now define our producer threads. So we are going to have like two threads, two list of threads actually. One is for producer and the other is for consumer. All right. So we'll be only consuming when we are done with like all of the uh, like enqueuing stuff. So so that we just have like all of the uh, to all of the messages in the queue first, and then only we start consuming. We could like use something as thread dot join to like achieve that. So yeah, let's see if we could like actually do that. So let's first get our producer threads. So let's create one thread array. Let's name it producer thread and new thread. The size of it would be thread pool size. Makes sense. And so we have like all of our threads now. What we need to do. So before this, we'd also like need a runnable class that we will be feeding to this threads, and that runnable class would actually be encoding all of this values to the queue. So let's first like loop for the total number of threads that we have, like int I is equals to 0 to I is less than my thread pool size to I plus plus. So since this many of threads we have, we could like assign like X amount of jobs to one thread, and similarly we could like evenly distribute all the jobs to all the available threads we have from the thread pool. So let's say for example uh, we have like 10 uh, items that we want to enqueue, then 10 divided by how many queues we have. So for the convenience, let's say we have 10 thread pools and 10 threads available in thread pool, and we have to enqueue like 100 items. All right, so it would be, so each thread could be handling like 10 items, right? So this is what I'm gonna do here. So for all the thread pools, I'm gonna like assign this many for all the threads, I'm gonna assign this many of items to a single thread, and they could like do their job separately. So yeah, let's implement that. So for I int equals to 0, I is less than thread pool size, I plus plus. What I want to do is like create a new thread and put that into there. So yeah, makes sense. So yeah, let's create a new thread. All right, we could actually assign it to the producer thread as well. Producer thread at I is equals to new thread, and it would be taking some kind of runnable, and that runnable is a producer runnable. Let's like just add that class private static class producer. This should be implementing runnable. Okay, let's just override or implement the required method, and let's just pass it here producer insert new. Okay, new producer. All right, okay. So what all things this producer know should know? So it should know like the number of items. So and number of items that it needs to enqueue. Then what else it needs to know? I think okay. It also should know this queue, but since it's a shared resource in this class as well, I think this would just get it. So yeah, let's try to do it for int I is equals to 0 to I is okay, I is less than the number of items and I plus plus. Okay, then my queue, let's okay, so this is not static, so it would not get it. So let's also get the queue in here. Queue of type integer and queue. Okay, so now queue dot add I. Okay, and also now just define the constructor for this. So yeah, I think we are good with the producer. Let's just pass these things into our producer in the thread. So number of items would be the number of item divided by thread pool size, right? And the other thing would be queue. All right, so just pass this queue. Makes sense. And then I'll just kick off this thread. So it should be producer the thread I dot start. So I think this makes sense still here. There's one issue though. So let's say it won't keep the like count of item that I'm inserting, and later it would be like it would be easier if you could just like just sequentially add to the queue so that we could like see, yeah, this many of our items has been inserted, or we could just like see the size of it later and see like whether it is 1 million or not. Yeah, either of that makes sense. I think we could just like move ahead with this one. So we have this now. What we can do is arrays dot string what's the array producer thread dot arrays dot string. What I need to do is to for each thread, let's do thread dot join. Okay, so it surrounds with try catch. Cool. So what we are doing in here is like we are waiting for all of the producer thread to like insert all of the items that it has been assigned to the queue. Once that is done, we could like do the same thing with the consumer. Let's call it consumer thread. Before this, we can just first test this, right? So let's do something in here. So let's print out queue.size. Let's see how many of items that we're getting here. Okay, so think till here it looks fine. Let's see how many of item it has in queued first. We could just run this. So it's around 3,37,152. So yeah, it's a lot less than what we would have expected. So yeah, that is because of the threads, and they are just accessing the like same resource at the single point, and they might be adding at the same point, and hence like not seeing the actual count in here. But yeah, let's move ahead and complete the consumer part as well, and then let's try to fix it with logs, and let's see like if we are able to do that or not. All right, so let's uncomment this part. Okay, let's leave it as it is. Let's uncomment this. Okay, consumer thread pool size, got it. No need of this explanation in here. For I is equals to 0, consumer thread at I is equals to this, consumer thread at I dot start. Let's define our consumer class as well. Let's call it consumer. And also gonna have the number of items. That's gonna TQ, then the queue. Let's call it consumer. and then for this many of times it's gonna pool. Yeah, I think we are good with our consumer class. Now let's change this one. Alright, so triple size queue. For each of the consumer thread, I want to join it so that it finishes. Alright, now let's again print the queue dot size. Okay, now let's see what does it return. Okay, so yeah, something similar, but yeah, still like has not decayed everything, and I also believe that it would change every time I run it. Yeah, you see, the funny thing is it's just, yeah, there's a difference. All right, so now let's try to fix this. Let's introduce one shared log. Now call it reentrant log, maybe something like that. Reentrant log. We have introduced the new reentrant log and how to use it. So this producer consumer also gonna need this log. I think reentrant log is child of the actual log object. Yeah, class, sorry. Okay, let's add a log in here as well. Okay, so this too has got logs, and it should also be in the constructor. There's in here, cool. Let's add to the other constructor as well. Okay, so added into the both of the constructor. Let's call it in the caller context as well. Pass the log. Okay, pass the log. There is an issue. Initialize variable log. Okay. Let's do it like this. Log is equals to new reentrant log. I think it should be fine now. Cool, so we have passed the log. Now let's cover it with log whenever we are adding and also pulling. Okay, so log.log try, let's try this. Okay, now finally log.unlock. Let's see if it makes any changes or not. Okay, so now you see we are able to add all of this 1 million of items because of the queue. So what this lock is doing, it is basically just synchronizing this part of basically the queue.add method so that only single thread could like access this, and not two different threads are like just adding to the same location of the queue, and hence we are just getting all of the like 1 million of items into the queue. Let's do the same thing to the consumer as well, and at the end we should like see the queue size should be 0 like when it has like consumed every messages from it. So yeah, or the items from it basically. So let's see in here, yeah. Try log.log, and I'll do this, then finally log dot unlock. Yeah, let's save it, let's run it. Let's see if, yeah, we get the 0. So yeah, I think this seems to be working fine, and uh, I think we have like demonstrated what we actually aimed for, and see like how the use of locks are like really important. Synchronization of code is really important whenever we are using multiple threads in our system, right? And also like how the different threads are like uh, executing in concurrent, and also like uh, maintaining the size of the queue as it should be by handling the like this resources and the locking of it properly. So yeah, I think uh, we are good here, but yeah, I will just try to do the same thing what we have done here through the executor framework as well, because that is like one of the most prevalent multi-threading framework from Java, or the concurrent framework from Java, and it just let us handle the threads like really easily. So yeah, once we understand this one, or like once you are able to like write this by your own, we should like, or you should like really explore the executor framework as well. So yeah, I think that is all from my side. Thanks for watching.